8.3 Systems of Equations. Now this is doing our systems of equations instead of by substitution. Now we're doing these by elimination. Okay, so this is it. This is the last chapter or the last part of the last chapter. After today, I'm going to try and get the review on for Wednesday, and then Friday is the test, and then that's it. You're done pre-calc 11. So let's get into this one. What is this? Okay, so solving a systems of equations. Remember, a system means two or more, and these can be done algebraically. Now, first off, we did substitution. Now, the other one is by elimination. So here's what we're going to do. We're going to be adding or subtracting multiples of the equations in order to get one of them to eliminate. So in order to eliminate one of the variables. So one of them is going to disappear. The other one will stick around. We'll solve for that. So for example, here's an equation. This is a linear equation. This is a linear equation. You did these last year. Now you did them by graphing two lines or by substitution. But look, 2x, 4x, 5y, 11y. If I was to double this one, and I'm going to do that, double it times 2, right? Multiply everything by 2. This becomes a 4x. 4x, it's the same. So I've made the equations, well, I've made the variables the same. What I've done is I've equated the coefficients. So watch, I'm going to double this and I'm going to put it underneath. So 4x plus, and then it's 10y, and then plus 19. Hang on, 19 doubled is 38. Okay, equal to 2 times 0, still 0. Now, should I add these two equations together? Nope. You know what I'm going to do? I'm going to subtract them. Why? Because 4x minus 4x is 0x. There's no x's. It just disappeared. Fantastic. That's what I want. What about the other stuff? It doesn't disappear. So 11y take away 10y, that's 1y. 12 minus 38. Sorry, minus 12 subtract off 38 is going to give me minus 50 is equal to 0. Well, you know what? Move over the 50. Here we go. Y is equal to 50. And then once I got y, I can probably figure out the other one, right? I could plug in 50 into here, I could plug in 50 here, either one. I can use that to figure out what x is equal to, but I don't really care about that right now. Why didn't I just use substitution? Substitution always works, right? We love substitution. Well, if you wanted to solve for x or y, right, solving for x here, you'd have to divide everything by 2, 19 over 2. Solving bar y, you'd have to divide everything by 5, 19 over 5. Not nice. Same thing here. I'd be either dividing everything by 4, it's going to give me 11 quarters, or dividing by 11, 12, 11. Yeah, no matter what. I could have eliminated one of the variables, but I would have got ugly fractions, right? And if you don't like fractions, that's what you want to avoid, if possible. Now, sometimes you can't, but in this one, I didn't have any fractions. So here's what we did. We eliminated one of the variables. And once we do that, you can solve for the other variable, right? So once I've eliminated the y, I'm solving for x. Or once I'm eliminating the x, I'm solving for y. So the other variable, and once you solve for one, and then you're going to sub back in. Yeah, substitute this y is equal to 50, plug it into here, and you figure out what x is. It's just faster to use substitution for the second part. But here's the most important thing. When I add and subtract, notice the x minus the x, there's no x's. Now, if there were still x's, I have another equation with x and y, which is not helpful. Okay, so the most important factor here is that one of the variables must be completely eliminated. So the variable, whatever it is, either x or y, must be completely eliminated. Eliminated. In other words, see this one, it's got x squareds and x's. Now it's not just enough to get rid of the x squared. The x needs to disappear as well. So both of them, all traces of x have to disappear. Then I've got an equation in y and I can solve, right? So for that reason, what some people always do, they always get rid of the y. And I don't care what the x's are, I'll solve that equation. But see, there's an x squared and there's an x. If I was to try and use this one to get rid of this, it doesn't take care of the x squared. Not quite. Boop, it's still there. So here's what we're going to do. I'm going to, let's see, 2y, 2. You know what I should probably do? I should probably rearrange this. Notice the order. This one goes x squared, x, y's, and then equal to 0. This one has got x's, y's equal to number, right? So maybe what I'm going to do is I'm going to do this. I'm going to go 5x minus y minus 10 is equal to 0. So that way I've got the number in the third column. Actually, you know what? This one doesn't have a number there. It's not really going to be necessary. But I do need to rearrange the order of stuff, right? X squareds are first, then x's. There's no x squareds, then x's. See, the y's come after, the y's come after. So the order is going to be important. Okay, so let's just focus on that. I've got minus 2y. Here I've got minus 1y. So if I double this one, this becomes 10, 2y, and 20. Then I've made the two y's the same, right? I've equated the coefficients. So what am I going to do? I'll probably multiply this one by 2. But watch, you know what I'm going to do? I'm going to multiply it by negative 2. Why? Watch. So I've got 5 times negative 2. Boop. This gives me, there's nothing in there. This gives me negative 10x. Okay. Negative y times negative 2 gives me plus 2y. And on the equal to, 10 times negative 2 is negative 20. Why did I do that? Because look, I've got a minus 2y and a plus 2y. So in this case, I should be adding the two. So I didn't really equate them, but I made one the opposite of the other. So I made a plus 2y and a minus 2y because I'm faster at adding than I am subtracting, right? If you want to do that, some people do always do that. They make them the same but opposite sides because when I add these two together, 0 plus negative 20 is negative 20, right? These cancel. There's no y's. And here I've got 10x, sorry, I got an x squared. And when I add these two together, I get a minus 9x. Okay, so I'm going to take this 20, move it on over, and guess what? Look what we get. X squared minus 9x plus 20 equal to, that's a quadratic. Yay! And it's an easy quadratic. I can factor this one. Okay, cool. Two numbers multiplied at 20. It's got to be 4 and 5, but they add up to negative, so it's minus 4 minus 5. Yay, that factored. Now, why is this wrong? This is currently wrong. What? Because I had an equation. This is an expression. Remember, it's still an equation, still got to equal 0. That's really the important part. Because now that it's equal to 0, I can use my 0 property, which means x minus 4 is equal to 0. X minus 4 is equal to 0. You know what that means. You know that that means x is equal to 4. And x minus 5, that means x is equal to 5. So I get two different sets of solutions, right? So if x is equal to 4, I should probably plug it. Should I plug it into this equation or should I plug it into this equation? Hang on, they'll both work, right? I should plug it into the easiest one possible. Make your life easy, right? I'm plugging in x equal to 4 into there. So you could do it into here if you really wanted to, but let's not. Let's just say, look, I know that 5x, no, 5 not times x. What is this? It's not 5x, it's 5 times 4, right? Because x is equal to 4. 5 times 4 minus y is equal to 10. So 20 minus y is equal to 10. Subtract off, this has got to be 10. It's 20 minus 10. I know that y is equal to 10. So there's my first solution. The x value is 4, the y value is 10. That's a point where they cross. Now, let's do it again. 5 times x minus y is equal to, so 5 times x, 5 times 5, minus y is equal to 10. So this is 25 minus y is 10. Remember, minus 25 minus 25. I'm going to, minus y is minus 15. Y is going to equal positive 15. And that makes sense. 25 minus 15. So here's my other solution. When the x value is 5, the y value is 15. So I get two actual x and y points. So there's 2 points of intersection. Well, it makes sense because this thing's a parabola and this thing's the line, right? I'm expecting to get 2 points. Okay, I'll get rid of those. Are they right? Maybe. If the question asks you to check, and you know what? Okay, let's just do a check for this one, but we're not going to do it for all of them, right? We'll do a check for this one. Okay. If they actually ask you to do a check, you have to take your point 4, 10 and plug it into both equations. It's got to work in both. So 5x minus y equal to 10. 5 times x, which is 5 times 4, minus y, which is 10, is equal to 10. I'm going to get 20 minus 10 is 10. Yes, it works. But let's do it in the other one as well. Okay, hang on. x squared plus x minus 2y equal to 0. X squared, so 4 squared. 16 plus 4 minus 2 times y. 2 times 10 is equal to 0. This is 20 minus 20. Yes, it works. Yay! Okay, hang on. Let's check my other one over here too. Okay, yes, these questions tend to take up an entire page. So now here's my solution, 5 and 15. So the first one's usually the easy one. 5x minus y is equal to 10. So in other words, 5 times 5, 25, minus 15 is equal to 10. Yes, I know that's true. In fact, that's how I got my 15. But this is the one that's going to be harder. So x squared plus x minus 2y is equal to 0. So 5 squared, 25, plus 5, minus 2 times y. 2 times 15, 30 minus 30. Yes, that's 0. Yay. So this one does work. There's one set of answers, right? 4 comma 10. Here's the other one, 5, 15. So we were forced to eliminate the y variable of this one. We were. It's true. See, we got rid of the y's, and we got an equation with x. Then we solved for x, and then we subbed it back in. Why couldn't you get rid of the y's, right? So if I get this y and this y to cancel out, if I double this one, or no, if I was to try and do the other one, sorry, let's say this again. What if you were trying to get rid of the x's? I've got a 5x, I've got an x squared. Those don't cancel. Now the 5x can cancel this one, right? However, there is no x squared there. So it's not going to work. So for some reason, what some people say is I'm always going to eliminate y. And you know what? Because these things are functions, that'll work. It will, right? So the reason that we were forced to eliminate the y is because the first equation had no, I didn't have x squared in both. So x squared was only in the second equation, not in the first, right? So if it was in the first one, then I could try and get it, but it would not completely eliminate. Okay, so let's try this one. 3x squared, 6x squared. Yeah. X, 4x. So I can cancel out the x squareds, I can cancel out the x's. Y, hang on, this is already ready to go. See, minus y, they're already the same. They're already equal. Maybe I should try and get rid of the y. Well, if I wanted to do this one, let's see, I could double this one, right? Watch, if I double it, I get 6x squared minus 2x minus 2y minus 4 is equal to 0. So I know that the 6x squareds are going to cancel, but the 4x and the x's don't cancel. They don't, right? So if I was to try and cancel out the x's, it's not going to work for this one. So that's a reason why. Think about it. See what I got? And besides, the y's are already ready to go. They're primed and it's already in perfect condition. Let's get rid of the y's. Let's do that. Okay, so here's what I'm going to do. I'm going to put this one underneath. Really important, you got to match up numbers and stuff like that. So 3x squared goes underneath the x squared. Minus x goes underneath the x. Minus y goes underneath the y. 2 is a number, but you know what? I'm going to move it over to the other side. I'm going to go plus 2, plus 2. So I'm going to get a plus 2 over here. Excellent. Now what? Add them? Subtract them? These are the exact same. I have to subtract. If I was to add them, they wouldn't cancel, right? So let's subtract. 6x squared minus 3, that's 3x squared, done. 4x minus minus, think about it, minus minus, right? That's going to be plus 5x. Minus y minus minus, these are the same. They're going to cancel each other out. 4 minus 2, 2. Move this over, and I should probably recognize this. 3x squared plus 5x minus 2 is equal to 0. Yes, this is a quadratic. Now, I could either go to the quadratic formula, right? Or I could just do a decomposition. Yeah, hang on. 3 times 2. So two numbers that multiply to negative 6, and they add up to positive 5. They multiply to a negative, which means one's positive, one's negative. So it's 3 and 2? No, can't be 3 and 2, because that wouldn't add up to 5. What about 6 and 1? 6 and 1? That'll work. Yes, there it is. So plus 6 minus 1. So remember, don't do this because this is wrong. We know that this is wrong. I can't go straight to there. Oh yeah, because this is a 3x. So decomposition, oh, that's right. That's where I need to separate the middle. Okay, so I'll go 3x squared and I'll go plus 6x. And then this becomes minus 1x, and then I've got the minus 2. Remember, still equal to 0. So these first two, I should be able to factor out 3x, bracket, x plus 2. These two, I can factor out minus 1, bracket, x plus 2, right? Negative 2 divided by negative 1. Okay, there we go. Excellent. I can see it right now because x plus 2, it's the same factor. That's what I'm looking for. Remember, that's going to be one of my factors, x plus 2. Here's my other factor, 3x minus 1. 3x minus 1. Remember, it's still equal to 0. The important thing about being equal to 0, now I can use the 0 property. So what number plus 2 would give me 0? X must be negative 2. That's one solution. And the other one would be 3x minus 1 equal to 0, plus 1, 3x equal to 1. You know the shortcut. No. We don't have to show all that. I know what it's going to be. It's going to be 1/3. Or is it negative 1/3? Hang on. This becomes, right? The 1 would go over, it becomes positive 1, and then I would go divide by 3. There we go. So there's my 2s solution. Oh, hang on. These are my 2x solutions. I need to figure out my y solutions. Okay, so how do I do that? I could either start, no, I can't start over. Take this, substitute it into either one of these equations. Now, they're both pretty big, right? But it'll work. Let's try it. So let's go with this one. So I'm going to plug in negative 2. So here we go. So this one, let's just go over here. 3x squared minus x, make sure you use brackets, right? Because you know that these are going to change. Minus y minus 2 is equal to 0. You know what? As I'm writing it down, I'm just going to switch that right now. Because I put this over and I got equal to 2. It's just going to make my life easier. Negative 2 squares 4. 3. So this is 12 plus 2 minus y is equal to 2. So in other words, 14 minus y is equal to 2. Minus off 14 from both sides. Minus y is minus 12. That means y is positive 12. Oh, not x. I've already done x. So when the x value is negative 2, the y value is 12. That's an x and y point. Okay, let's do the other one over here. So 1/3, yikes. But you know what? I'm going to be squaring it and multiplying. This should work out. Let's try it. So 3 times x squared minus x minus y equal to, remember, I moved that over. It's equal to positive 2. So this is 1/3. 3 times a third is 3, or sorry, 1/3 squared is a ninth. This is 3/9 minus a third. 3/9 is a third. A third minus a third. These two cancel. Gone. So I just get minus y is equal to 2. In other words, y is equal to negative 2. There's my other point. When the x value is 1/3, my y value is minus 2. I'm not going to check these. We know how you do that. You'd have to plug them in, but I'm not going to make you check something like that by hand. These are just ugly. If the question said validate your answer or prove that it's right, you know what? I might just graph these, right? Because I know I have a graphing calculator, and if you graph this and graph this, they're two parabolas. They're going to cross at these 2 points. Okay, so what have we done here? Okay, so quite often you may have to rearrange these things. See, x squared, xy equal to number. You might have to rearrange them in order to line up your variables and stuff. So you may have to rearrange the equations. So in order to line up variables, numbers, equal signs, right, constants, whatever, it pays to be organized here. They have to match up. Now, I'm going to multiply either one of the equations or maybe both of them by a constant, right, by a number. Quite often I doubled one of the equations in order to equate one of the variables. Once the variables are the same, then I can actually get stuff to cancel. Okay, I'm going to add or subtract to eliminate a variable. Eliminate a variable. And once I eliminate one of the variables, then I'm going to solve for the remaining one. So if you eliminate the x, now you can go back and solve for y, and the other way around. Once you get one of them, then I want to substitute it back in. Substitute. I mean, yes, you could start over, but it's faster to do substitution. Substitute it back in order to determine the other variable. And if they do ask you to verify or check, so if you have to verify your answers by substituting into both equations or both functions, Yes, that's really, if it says check your answers, you know what? I'm going to say, or graph these things, right? If you can graph it, if you got a graphing calculator, we know that that's a fast way of doing it. Now, why are we doing all of this stuff by elimination? Excellent question. These are big questions. Because, remember back to this beginning one? If I try and do it by substitution, I know I'm going to get ugly fractions, right? Now, if you're okay with the fractions, great, do it by substitution. But the reason why some people really like elimination is because you can avoid the fractions. Avoid your fractions. So you can do these things in whole number multiples and they should work. Okay, this is it. Page 452. Now, this is like a 5-part question. This is a lot of work. And then these are 3 individual word problems. So this is the big question here. So this is the last section in 8.3. And then, yeah, Wednesday, I'm going to have a practice test or some review on there, and I will make up a video for it. So the video is going to be the important thing, right? So watch for the video on Wednesday for the review video. Because that's where I'm going to go through the questions and how I'm going to be doing these things, what I'm thinking about, and watch out for pitfalls. Alrighty, good luck.